From Hungary, representing Flex, we welcome an expert in production processes and simulation. Gergely Popovics has been responsible for implementing advanced FlexSim models in international projects, helping to optimize operation in one of the largest manufacturing companies in the world. Today, he will present his experience in applying simulation to global scale production. Please welcome Gergely Popovics.
Earlier in my career, I worked at small or middle-sized companies where simulation projects came in occasionally, after each other, or totally randomly. This was sometimes a challenge to manage these projects. It was hard to find the right balance between meeting the deadlines but avoid long periods of idle time. Now, picture a company which runs over 100 simulation projects a year. This is a totally different challenge, as you imagine. It requires a totally different way of thinking about simulation models and simulation project management. Today, I will show you how we manage them in Flex, which is a large multinational company. I'm Gergely Popovics, a simulation engineering manager in Flex. Let me start with the short agenda about my presentation. I will tell you some words about Flex to our company to see the scale of it, and then I will tell you some words about the group, our global group, who are supporting the simulation projects and the digital twin projects. And then I will tell you how we use FlexSim for that, and I will give you a short summary at the end. As you see on this slide, in Flex, we have more than 100 locations worldwide. Most of them are manufacturing facilities, and we have also many employees. More than 140,000 people are working with Flex right now. As you may know, Flex is a contract manufacturing company, so we produce semi-finished or finished goods for our customers, which are mostly interested in different technologies like automotive, data centers, industrial, health solutions, and so on. So for serving their needs, we need to apply many technologies like surface mounting technologies, plastic molding technologies, assembly, even metal sheet technologies or logistics. So as you imagine, this creates a very complex operation. Adding to that, we have many different customers with their various needs. So to serve them, we are running a very complex processes. So simulation at this scale needs strategy, not just shortcuts. So let me tell you how we solve this problem in our global team. I'm a member of a global simulation team in Flex. So our vision is to differentiate Flex as a technology leader by deploying digital twin solutions across the entire company. For that, we use real-time and historical information related tools. So our tools are relying on real-time data and historical information. We use state-of-the-art digital tools and technologies like, as we heard, artificial intelligence, virtual reality, machine learning, and so on, you name it. Our main business value, as I said, it's competitive advantage, to make competitive advantage against our competitors. Then we also provide better understanding of our business processes through this simulation and digital twin projects. As we heard before, actually, in the presentation, to going through these very complex projects, sometimes we unreveal or have more insights about the business processes themselves. So we also provide that. As we make these simulation projects, we create actionable insights through optimization and preventative analysis. And ultimately, we increase the customer credibility and acceptance. In fact, we have some customers who are specifically asked for simulation analysis before a new product introduction. So let me quickly tell you about our organization. Basically, we are divided to three main subgroups. The first one is the application development and digital twin team led by Sergio Vargas. So their main task is to create applications supporting the simulation groups. We have 3 simulation groups, one for each region, one for Americas, one for Asia. These 2 are led by my colleague Diana Ceballos, and I am responsible for the European simulation team, and also I'm responsible for research and development activities in this field. So let's see how we created the strategy of handling that many simulation projects and digital twin projects. We have a strategy which stands on 4 main pillars. The first one are the trainings. The first one is a training program what we created to build local competence. When we train people locally on the sites, after the training they are able to make smaller or not that much complex simulation models, so we win a lot of time. So we created this multi-level training in 4 languages. It starts with the short introduction to the technology, then continues with the visualization part, because we saw that many many projects are mostly just for visualization, to better understanding the process by its visuals. Then the training becomes a bit more scientific. With the simulation levels, we have 3 levels of simulation, and the last one is the digital twin. That's the highest level of our training. So the next pillar is the standard. So we created standard procedures because we want to accelerate the projects. So if we have standard templates, standard bricks, we can easily build a simulation model, and we can sustain the high quality of our simulation projects. We also created other templates. As I said, the training program is already a standardized program. We created a 3D library, the 3-dimensional component library, which contains of more than 500 3D components what we can easily use in our simulation models, so we can just download and drag and drop them into our model. So that's how we accelerate the simulation model building. We created standards and templates for inputting data input, and the connections between the simulation model and any data source. We also created some model templates for some smaller problems, like very typical example is an SMT line. So many SMT lines are somewhat similar. So we created a template SMT line, which anyone can use, download, set the parameters, and run very simple experiments. And after that, if they need, they can make details, they can implement details into that model template. So that's, again, something how we accelerate the simulation projects. We created also templates for showing the results, creating reports. Usually we use Tableau, which is an interactive data visualization tool. I think it is a lot easier to see the deep insights, to analyze our results if the charts are interactive. So it's a lot easier to sort them, it's a lot easier to filter them, so I think it helps a lot. We also created templates for creating videos, some model development guidelines. We created also some samples and templates, and of course about documentations we have many templates. So the next big pillar is the projects themselves. So in case of more complex or bigger projects, we also serve our customers, even internally or externally. So our global team categorized the projects into 3 categories. The first one is the visualization. Mostly it's just a 3D model where the user can walk through and see the planned production line, for example, in this example. By the way, mostly we don't use FlexSim for that, because as you see, this is more realistic view of this 3D model, and I think the biggest benefit of FlexSim is not that. So in these models, we just create a 3D static model, and we create an application to the customer, so they are able to go through the production area. The next category is simulation. So mostly we make simulation analysis on production cells. This is a very typical example. We created a simulation model about a production cell before implementation, so we can analyze the bottlenecks. We can spot the weak points. As we heard before, actually, this is a very, very typical application of simulations. So this category has already some intelligence in it, because it inherently contains the rules, the logics of the real system, but it doesn't have any real data connection between the simulation model and the data sources. So the last big category serves that. It's the digital twin, where we connect the 3D model with live systems. So they are in live connection with our MES systems. Of course, it's a 3D visualization model, 3D model in the background. So in this example, we created a 3D model about an entire facility, an entire campus, and the user is able to click on any of the production halls and see the stations in real time. So these data are coming from the MES live systems, so they are live data. It is very useful for the production engineers. Last big pillar is the research. So as we found, digital twins are the next frontier of factory optimization. And according to Autodesk's definitions, there are 5 different levels of digital twins. And in one of our solutions, we aimed to get to the level of the informative twin, which shows the operational and sensory data. So we created a standardized digital shadow tool, which enables quick implementation in any of our sites. The first step of an implementation is to create a FlexSim model, but we use standardized elements. Those are predefined. We have a library for them, and if we implement them into the simulation model, it's very easy to make a reference between the simulation model and the MES system records. So there is a reference between the simulation model and the MES database. Then, once we built up the entire simulation model, we transfer it to the digital shadow application, which is a 3-dimensional visualization tool, so we can see immediately the values and the measures of the production line in real time. So that's the most important thing. These values are live data. Moving forward, we saw that solving problems is not always the best solution. It's even better to prevent them, right? So we aim to create another application for reaching level 4 digital twin, which is a comprehensive digital twin. So we can make future scenarios, we can make what-if scenarios and tests. So for that, we created an application, what we named Simon, which is a scalable forecasting digital twin application. But what does this title mean, right? It's pretty long. So the scalable means for us that it is easy to deploy to each site. So due to its modular structure, it's easy to modify or replace any of the modules. For example, the simulation model can be replaced to another one very easily, you will see later. It's a forecasting tool because we start from the current state and run it to the future. It's a digital twin because it's connected directly to the real MES systems. And it's an application because we created a web user interface, a web application for the users who are not skilled in creating simulation models. So the engineers who we never trained can also use this tool without any knowledge about simulation, and they can run simulation analysis without knowing that they are running a simulation model actually. So once the user press run on the application, a trigger is fired in FlexSim. There's a model running on a server with the most basic data like the username, the run ID, and so on. And it retrieves or collects data from the MES live systems running in the factory. But why is it so important to have live connection, right? Firstly, because we can see the actual state. So we can see, for example, the actual VIP levels of the production floor. We can see, for example, the available resources at the moment. We can see the most up-to-date production plans, so we can run that. So once we retrieved all the actual data from the MES systems, we can start running the simulation model, starting from the actual situation to the future. So the results are sent back to this web application and visualized with Tableau. So the user is happy that he will see what will happen in the next days or next week. Or is he? I mean, what if he is not happy with the results? What if the values are not in the accepted range or something is lower than he expected? Then what does he do? He runs the simulation again, right? No, he doesn't run the simulation again because doing the same thing over and over again doesn't make any sense. So we need to change something. So that's why we implemented this function in our web user interface to change some parameters. So for example, we can change the number of available resources. We can change the batch sizes. We can modify the production plans and then run the simulation model with these modified parameters. So we can see what would be the effects of changing something in the actual situation. And then the charts are different. The user is more happy, I believe, or I hope. So here you can see a demonstrational video how we used or how we are using this application. As I said, it's an interactive analytical tool, so we can sort, we can click on any of the charts, so it's a lot easier to analyze and see the most important data of that. Okay, so to give you a short summary about my presentation, as we saw, Flex is a very big company, very complex procedures. Basically, we have endless number of simulation projects, so we needed to came up with some novel solutions for that. We defined a standardized training program, other standard templates, standard procedures to accelerate the simulation projects and to sustain the high quality of them. And for the bigger or more complex projects, we as a global simulation team provide support for visualization, analysis, and digital twin projects. And we are also doing research and development activities to keep us on the competitive edge of this technology. So as we saw, Flex is a big company with a big complexity, so simulation in this scale needs strategy, not shortcuts, I think. Thank you.
Thank you very much. Thank you for your contribution, Gergely. Does anyone from the audience have a question to Gergely? It's a perfect time to ask now, or maybe later. Any of you? So, okay, there's one question. We got a microphone.
Thank you for presentation, firstly. And I have a question. You talk about simulation and digital twins. So digital twins is basically a simulation, but linked with sensors on real machines. But I don't understand why you do not do what-if analysis on models only, on simulation, and you only do what-if analysis on digital twins. Do you need this connection to data, or can't we just make a model not linked with data to do what-if analysis?
Yeah, thank you for this question. Actually, I didn't mention that, of course, we make what-if analysis on simulation models as well. Yeah, it's my fault I didn't mention that. Yeah, we can also make even series of experiments on simulation models or even mathematical optimization on simulation models. But we wanted to distinguish between the simulation analysis and the digital twin project, so that because it's simply easier for us to distinguish them like this.
With the digital twin, it's just an extension in a close future, let's say, like what's going to happen in the next hours, next days, since the current state that is real. It's not virtual.
Again, please, sorry, I didn't get the beginning of the question.
The what-if analysis linked with the digital twin is just an extension. Like we start from the real situation of our plant, let's say, and we wait to see what's going to happen in the next future.
Yes, so in many cases about simulation project, we don't even have the system itself. So it's not possible to connect it to the real system, of course. But that's a very good point, that the main difference between the simulation and the digital twin is the connection to start from the actual situation. So yes, actually that's the main point. So when we create a simulation model about an existing system, it's very, very similar to a digital twin in our understanding, except the live connection.
Thank you.
So I got a question for you about how you cooperate with your sub-suppliers on two bases. For standard machines, how do you prepare those models for the database, right? And how later do you connect them with the MES? Is it like a template that you can just connect to your MES, right? Or you are approaching this every time for the new installation? And for the full assembly lines for the backend assembly, this is usually custom made for you. And on the offering stage, usually it's just the imagination. It's not realistic model yet, or later in the design. So how do you tackle this problem? Because usually on the first stage of preparation of the full line, there is not existing realistic model. So how do you tackle this problem? Or you return to the simulation in the later stage of the designs, right? So.
Yeah, so let me answer the first question first. So you asked if so how we handle our sub-customers, how we retrieve sub-suppliers.
Preparation of the models.
Yes, how do we prepare the model based on their specific machines, right? What they provide. Yes, we have this library that I told you before. So for the bigger suppliers, we already created these 3D models. For the smaller ones or the ones which are unique, we need to create them on the fly. So during the simulation project, we need to build or create those 3D objects with their specific behavior. In some cases, we can collect the 3D, or we can receive the 3D drawing of the machine, but it's very rare. And answering your second question, as the before implementation phase of a project, we usually create simulation analysis, simulation models, whenever we have enough information, enough data to make simulation runs, and when it makes sense to analyze something. But further, in the project, when something is changing, maybe based on our results, we can modify the plans, we can modify the simulation models, so we can run the analysis again. Did I answer your question?
Yeah. Yes, more or less. And do you prepare the full models for FlexSim, or you are just getting the models from, let's say, ISM or Panasonic or Fuji? You are getting the 3D model and you are preparing the model with all the parameters, or they are giving you the existing model for the FlexSim that you can just plug and play in the FlexSim?
So let's distinguish between the 3D shape and the behavior, because the 3D shapes are mostly available in any libraries. We created some which were not available, so the 3D shapes are available in our internal library, but the behavior is usually not not programmed in advance. So we need to make that ourselves. Yeah.
What was the process of selecting FlexSim as a simulation tool, and why FlexSim?
That's a good question, because when I joined Flex, this was already a standard tool for simulations. But actually, to be honest, in my previous workplace, I was the only simulation engineer there. And when I entered that company, my boss asked me to pick one simulation program, one simulation application, what I will use. He doesn't care what that is, but make a research and pick one. And before that, I had been working with plant simulation for more than 10 years, so I was sure that I will use plant simulation further on. But actually making that research, so I was very surprised that FlexSim was a lot better that time with the 3D visualization. It was a lot easier to use. It has this function of process flow, which is a visual coding platform or visual coding function. So I liked it a lot. So actually I told my boss that even if I have no experience in FlexSim, I want to use that one. And he said, okay, it's not a problem.
I would like to ask the question about how you manage the libraries that you create and that you shared with many users around the world. How you control the versions, revisions, and do you use a special dedicated platform for it? It is provided by the Autodesk. Maybe use an external platform. Could you explain a bit about it?
Yeah. So we started to create this 3D library, what I showed a few years ago. So we just extending it. I don't know how much the Autodesk's library available right now and how was it back that time. But actually we just started to collect the 3D objects, what we use very frequently. And we created a platform for that. Actually, Sergio, who I mentioned, and his team, the application development team, created a platform which can be used internally in Flex. So anyone can download the objects, they can rotate them in 3D if they want, but they are not able to change it. It's the responsibility of Sergio's team. So if you want to include a new model in the library, you need to contact them because they are responsible for the versions, they are responsible for the extensions of the 3D library.
So basically it is your internal solution?
Yes, it is. It is internal. Mm-hmm.
Hi, I have a question. You use simulation to run like some kind of scenario. So user make a plan and then you run this plan. The question is, why don't you use like predefined scenarios, let's say, instead of letting user to change some inputs if user unhappy, rather say, okay, I have like default scenario and then I vary it a bit and maybe even propose better scenarios than user could imagine, because I mean you can test it, right? And even if user happy, there might be something what make it even happier.
Mm-hmm. That's a very, very good point. Actually, that is our next step of development. So right now we are at the phase with this Simon application that the user themselves can run what-if scenarios, what they define with setting the parameters. But it's a very good point that next step would be to create optimization, to give a solution which meets a certain demand. So yes, that's our next step, actually. Thank you for that question.
Hi, my name is David from Singapore. I have two questions for you, especially on the last part where you have the web UI. First question will be, because you have mentioned that the modeler or the person who used the UI doesn't know that actually the model is running at the back end. So firstly, does he actually build the model himself, or actually there is already a standard template that he will just input the data and run that at the back end? Yeah, so that's my first question. Second question, what happens if that he want to do some what-if analysis with the data that is a result that is returned? So he want to do some changing of the line balance kind of stuff. Will he be able to actually use the same UI to do this adjustment? Thank you.
Yeah, these are both very good questions. Thank you for them. So the simulation model is running in the background, and it's not built by the user. So our aim was to provide capabilities or possibilities for the engineers who are not skilled in simulation modeling. So we create the simulation model for them, specifically for their project, and they can use it every day. So they can run the simulation even every hour or every day if they want. So they don't need to build a simulation model. If they want to modify something, they need to contact us, and maybe we implement some minor details what was missing before. The second question was about the what-if analysis, right? So we also need to define in advance what parameters they want to change. Of course, we need to implement them or customize the user interface for their needs. So that's why I mentioned that it's relatively easy to implement this application is relatively easy to implement in many sites because it is modular, but it's about 80% finished. So the last 20% is customization, like the parameters. So from project to project, these parameters can be different, so we need to customize them. Also, the simulation model, we need to customize them for a specific project.
Okay, thank you once again. Let's upload Gergely for his presentation and Q&A session.
Thank you.